This is Remy to the Isabel, bringing you episode 2 of, well, just read the description yourself. So, quantum Bogodynamics. The name may sound silly, but this theory could potentially explain a lot of things that you were wondering about. So first off, Bogodynamics is the scientific field which studies bogons, which are basically particles which are smaller than quarks, and they actually have no mass. Now, when a bogon strikes a particle, oftentimes it does nothing. Yet because of the, what is it, not a Bogo Valley, the Bogo potential, because of Bogo potential that a lot of particles have, often when one bogon successfully strikes a particle, there's a cascading energy, like in solids at least, there's, it releases a lot of Bogo energy. That's not the word, but basically, because the particle can be pushed out of its stable energy equilibrium, the particle drops in Bogo potential, and that creates the let's just say Bogo energy for now. And so what this really is, it's not energy, because the bogons can't actually carry energy. Yeah, I know, they don't have mass, they don't have energy, but what they do carry is probability. Particles are just, you can look at them as a probability field, and you don't actually know, by Heisenberg's uncertainty principle, if you know how fast it's traveling, you don't know exactly where it is, and vice versa. So, for virtually all particles, you can never pinpoint exactly where the particle is and how fast it's traveling. If you know one, you don't know the other. And it's inversely correlated. So, because of this, we need observers to see where the particle is. But the bogon, what the bogon is it counts as an observer. And so when the bogon strikes a particle, if it successfully, basically every time a bogon strikes a particle, with the correct orientation of the bogon's velocity and the particle, it basically observes the particle, and all of that information about the particle is now like updated. So it can no longer have like a unstable wave field, or it can no longer have a diffuse field. That particle suddenly, for that instant in time, becomes a particle. And what a successful bogon strike does is it releases the particle's Bogo potential energy into the bogon. But remember, it's not energy, it's probability. So you have this, so it's not potential energy, so let's discard the Bogo energy concept, because that's not accurate. It's basically, it's releasing this probability to the bogon, which then, I don't know, we don't know what happens to the bogon when it receives that energy, but somehow it becomes more likely to have successful collisions with other particles after it receives the potential energy. And this sort of acts like the butterfly effect, because if you have one successful release of the Bogo potential, you actually can get, in solids, this cascade of bogons observing particles. And this has led to some interesting assertions, similar to the butterfly effect, where if you have a bogon in the right place going the right speed, carrying the correct probability, it can actually cause cascading reactions with particles, which because there's information carried by the bogon, can cascade up to higher levels where it's actually observable on the meta scale, the scale of size that we live in. And so it can affect brainwaves, it can affect radio signals, it can affect, in very controlled environments, it can affect air circulation. So hypothetically, bogons could affect weather. And so this is a very interesting field of science because it lets us understand more about open systems, right? In a closed system, there's nothing entering the system, there's nothing leaving the system, energy is maintained, and you can know everything about the system. But in an open system, you don't know everything about the system because there's constantly influx of new particles and energy and photons and all sorts of stuff. And the world is an open system. We're not self-enclosed. We have the sun, we have gas escaping to outer space, right? There's other planets which affect the gravity, right? So otherwise we wouldn't be orbiting the sun. And that, we get seasons. Anyways, and there's the moon, which helps with a lot of things like tides and air circulation. But the point is it's an open system, but it's also affected by probability. And that is where Bogodynamics comes in, because Bogodynamics has the potential to explain how improbable events can happen. It can explain why why a storm in the Pacific can become a full-fledged hurricane when it's not supposed to be that strong of a hurricane. It can explain why we have shifting ocean currents, right? There's a lot of possible configurations of ocean currents, same for air currents, but with Bogodynamics, if you have an accurate model of the system, you can guess which areas of BOGO activity in the atmosphere or ocean will lead to which results in the stabilized currents. And so with this, we can also make predictions and assessments of how did Donald Trump get elected? So this field of research definitely merits more grants, higher budget, because we really need to understand these critical issues about the world we live in. And Bogodynamics has the answer. Reminiscible out. And this is where I insert a shameless news plug. Play Dwarf Fortress!